Okay. Hi and welcome to the 11th and final lecture in the course Programming and Data Structures at the Linnaeus University in Sweden. The topic for today is written exam preparation. It means I will present an old written exam and I will show my solutions to it. And I will try to give you a few hints about how to prepare for a written exam. First of all, the exam, the first one will take place on March 18th, Friday. It is almost 2 weeks from now. It will most likely be at 8 o'clock until 1 o'clock. Most likely, since they haven't decided where it will be and when it will be. It depends on the number of students signing up for it. But in 90% of all cases, expect this time. Also, if you don't show up on this one, or if you fail, you will have a second attempt on April 16. Also, most likely 12 to 17. And a third opportunity to pass it will be announced later, but it will be after the summer break in the end of August. So you have 3 opportunities to pass this course, and if you fail, you will have to redo it next year. Questions about the setup? Have you all registered yourself? Very good. I think the rule says Wednesday the week before the exam, so it should be this upcoming Wednesday, I think is the last day. But don't wait until that date. Do it right away. The exact time and place will also be published 1 week in advance. Well, at the student portal, just follow the links to find where it should be. Have you tried this before to find the place? Did it work? Good. Let's jump to the first exercise. There are 5 exercises, and the first one this year was about recursion. Fibonacci sequence. The first 2 numbers are 0 and 1, and the others are the sum of the 2 previous numbers. So the Fibonacci sequence looks like this. Any number 5 is the sum of the 2 previous numbers in the sequence. What will be the number after 55? 89. Yeah. Write a recursive Java method int fib_n that computes the nth number in the Fibonacci sequence. We want you to write Java code here. We are saying that you should present a method, and we are giving you the signature here. So you should just implement this one. Also, why is the bow recursive method bad if you would like to compute the first 50 numbers? Motivate your answer. Also present Java code for a much better non-recursive approach to compute and print the first 50 numbers. Something like this. Also, finally, a simple exercise about recursion. Write a recursive method multiply int a or int b that computes the multiplication a and b using repeated additions. Do you understand the questions? Implementing the Fibonacci is straightforward. It is basically just writing down in Java code the definition of a Fibonacci number. We have 2 special cases. The special cases in recursion are called what? Base cases. If n equals 0, return 0. If n equals 1, return 1. Otherwise, return the sum of the 2 previous numbers. So this one starts a recursive call. If you would like to compute the Fibonacci, 50 Fibonacci number, you will call for 49 and 48 down here. So it is in order to compute it for 50, you need to know what it is for 49 and 48. So you make a call to solve these problems. This is a beautiful but a bad solution of computing this one. It will formally explode. For example, here I'm not sure whether you can see it, but I show the calls that are made when we are computing the 5th Fibonacci number. It will call Fibonacci 3 and 4 will call 2 and 3 will call, it will explode. The number of calls to the Fibonacci method grows exponentially. with the size of the Fibonacci number. So we are saying that the time complexity is an exponential in this case. It's not a good idea. If I do it on my computer, it stops at 30 or something like this. The computer cannot handle it anymore. A better way is to use a for statement like this. Anyway, the base cases are the same. If n equals 0, return 0. If n equals 1, return 1. Otherwise, we are initializing it like this, and then we are just iterating over the numbers here. We are computing the second number by adding these two values together, and then we are updating and say that for the next iteration the f0 will be f1 and f1 will have, and then we are just computing it. So we are in each iteration computing a new Fibonacci number. Very simple, and it can be done efficiently. Any problems with this one? Do you understand why this one is much better than the previous one? Yeah. What was the problem? I discussed this at the lecture time. What was the problem still using this approach? The Fibonacci number grows rather quickly, so at some point the 90th Fibonacci number it no longer fits in a long, so we are running out of integers basically. But that was not a part of the exercise. Recursive multiplication using addition. I am here, my basic approach here is based on this identity. A times b equals b plus a smaller case here, a minus 1 times b. So I can say that a multiplied by b, if a equals 0, we should return 0. Otherwise, it is b plus a minus 1 times b. It is b plus this one. And this is a recursive call. That's it. I think it was straightforward 10 points here. I know that students have a problem with recursion, and that's why I often include it in the written exam. So you shouldn't be able to get away from it. At least once in your life you should show that you know a bit about recursion. The second exercise is theoretic. What is an algorithm? What properties do we expect from an algorithm? Why do we use algorithms? Also, write an algorithm is pseudocode that is searching for an integer n in a sorted list using binary search. So we're asking you about algorithms, what it is, and also for you to show that you know what a binary search is. You should print down an algorithm in pseudocode for it. Do you remember binary search? What was the basic idea? What? Compare with the middle element and switch side, whether larger or smaller. What are the properties we do expect from an algorithm? What is an algorithm? That's the first question. Yeah, a precise description of how to solve a given problem. That's an algorithm. And what properties do we expect from an algorithm? Terminate was one of them. An algorithm is a step-by-step description of how to solve a problem. It should give an unambiguous result. It shouldn't say 1 or 2. It should point to say, given this input, this is the answer. It should give one and only one result. Be unambiguously presented. That means you shouldn't, the algorithm description shouldn't be vague. Basically, it should be possible to take the description and transform it into an implementation. It shouldn't contain any vague statements like, and then we pick a suitable number, or something like this. And that's the third one. As you mentioned, it should terminate after a finite number of steps. certain mathematical solutions can involve the limit goes to infinity or something like this. It's not involved. It's not correct in an algorithm. They must stop after a finite number of steps. Given the input, it should be possible to decide that, well, it will take a while, but if I do 3,648,000 computations, I'm done. So it should have a finite number of computations. Why algorithms? Well, most importantly, document problem solution and communicate problem solution. I come up with a very clever way of solving a problem. Of course, I don't want you to face the same problem or myself face the same problem. So I write it down once and for all in a proper way to reuse it, myself and other people. Also, we talked a bit about time complexity. You can estimate the number of computations needed to solve the problem. And in this way, you can compare different algorithms in the way they scale. You remember sorting algorithms. Insert and sort. What was the time complexity of insert and sort? What? N squared. That means the time to sort an array depends or proportional to n squared of the input size, the size of the array. And the better algorithms, like merge sort, they were faster. They were doing it in this way. So just by looking at the algorithm, the sorting algorithm, you can categorize it as this one or this one. And if this is true, this one will be faster. If the input size grows, this one will eventually always be faster. So we can compare different solutions if we just have them on the algorithm form. And also, as I said, I think algorithms is a good preparation before programming. Write down your algorithm, this is what you plan to do, and then you implement it. It will save you time in the long run. Don't start to do any programming before you have an idea about how to solve the problem. Exercise 2, binary search. Recursive version of binary search, initially called as, here I present how my algorithm down here should be used. I'm saying that initially you are calling it as ln1 max, where L is the list to be searched, n is the value to search for, 1 is the first index in the list, and max is the last index in the X. So this is how it should be used, and this is the algorithm. We are computing the mid position. The mid position is mean plus max divided by 2. We pick out this mid value, and if mid value is the one we are looking for, we are done. We have found the element. If the mid value is larger than the one we are looking for, we should search. If the mid value is larger than the one we are looking for, we should search in the left part of the array. That means we are repeating a binary search with the same array, searching for the same element, but now in a smaller range, minus to mid minus 1. Otherwise, if the value we are looking for is larger than the mid value, we are searching in the right part of the array. So basically the idea is that we are taking a look at the mid element here, and we are searching for some element n, and if this one is larger than this one, we should search in this part of it. Otherwise, we should search in this part of it. What was the time complexity of binary search? Logarithmic. All the problems where you are basically in a fixed number of computations, you are reducing the problem size by 50%. That's what we do here. We are doing one check here, and then we have reduced the problem size to an array which is half as large. If you can reduce it in a fixed number of steps, then it's logarithmic. Do you know any other thing we have presented in this course that have a logarithmic time complexity? Hashing? No. Yeah, binary search trees. We are entering in the root node, and then we are switching from left to right. And in just one step we have reduced half the problem. So search and insert in a binary search tree is logarithmic time complexity as well. Any questions about this one? Often when we are asking you to solve a problem like binary search, you come up with an algorithm, but it's also a good way to say how it should be used. For example, here I'm saying you should start by providing the first index and the final index to it. So, don't forget this one. Do not only present this one, because this one is actually not straightforward to interpret if I don't know how to use it. Data structures. Hashing is an implementation technique often used when implementing certain data structures. Describe how hashing works and why it is used. What type of data structures are you using hashing to implement? Hash sets. Set is one data structure where we're using hashing. What is the advantage of hashing? Very fast lookups. We can, in constant time, look up an element in a hash table if it is working properly. Also, what is a map? The Java interface util map describes a map or data table structure. What is a map and what operations do we associate with a map? Show with a Java example how maps can be used in Java. Hashing, this is from my lecture. The basic idea is that we have an array of linked lists. Each element here, a position and a list, is called a bucket. And what we do when we are inserting an element into a hash table is that we are associating the element. It might be a string, it might be a student, but we must associate it with a certain integer value called the hash value. For example, in my example, I said that we can compute the sum of all ASCII codes in a string. It is one way of associating each string with a specific integer value. This integer value can be of any type, any size. Then we apply the hash function, taking this integer and decide which bucket to use. And then we find a bucket, and then we insert it into the linked list here if it's not already there. That's the basic idea. And given the assumption that our hash function and this hash value provides an even distribution over all buckets, and that we have the same number of buckets as we have elements inserted, the average length of this list will be 1 in that case. And we have just a finite number of computations to check whether an element is there or not there. Did you get the idea? So we can add, remove, and check for lookup in constant time, but only if these conditions are true. If all elements are evenly distributed across all buckets and the number of elements are equal to the number of buckets, only in that case we can make sure that we have constant lookup time. Questions about hashing? You implemented it yourself in the third assignment. Did you check that you had an even distribution? Some of you did, I know. You should check. If you have made an implementation that everything ends up in the same bucket, we have a long linked, then it's pointless, then it's not hashing. A map. Have you used a map? A map is a data structure. It contains two key operations, put and get. Put means add a key and a value. Get means give me the value for a corresponding key. I have an example here. I have a hash map, which is a mapping from integer to strings. I insert a number of pairs using the put method. 1 is Jonas, 8 is Jesper, 64 is Jens, and so forth. This is the put method when we are adding data to the map, and this is where we are asking, give me the value for a given key. So we are asking, give me the value for 8, it will return Jesper. 4 will return Johan in this case. It is implemented using hashing in this case, and it's a commonly used data structure. You should know how it works. Give me the typical application for a hash map. A phone book. We have names as the key and in the phone number as the value. We are adding them, and you can easily then look up, well, give me the phone number for a certain guy. Inheritance. What is binding in object-oriented programming languages? What is the difference between static and dynamic binding? How does binding work in Java? This one was tricky. Not many students got it all right here. What is binding? Lucky for you that I usually don't have the same exercise as in this one. Binding, process of associating a call to a concrete target method M. In Java, when we are having polymorphic calls, the same call site in your code, you have written a code like this, it can target many different methods. And the binding is the process of decide what is the target of this call. Is it the method M in class A, or is it the method M in class B, or something like this? This is the binding process. We are separating static binding from dynamic binding. A call A is resolved using the static type, the declared type of A. That one is not changed. That means we can look it up at compile time, and binding takes place at compile time. That's called static. Dynamic binding, we are resolving a call used on the dynamic type, the current object value type of A. This might change from one call to another. That means only at runtime is it possible to decide where to jump next in this case. So binding takes place at runtime. We need to check what is the current object value here. Is it of type A or B or C? And then based on this information, we are finding which method M to execute. Java uses dynamic binding in all codes to non-static methods. So the standard case in Java is dynamic binding. That means at runtime we are deciding where to jump next when we see a call like this. And the rules, we have a call like this. We take a look at what object is currently stored in variable A. Assume that this is type X. If the method M is declared in the X, then we are calling this method. If not, we use M in the first superclass where M is defined. So we have a call A. It looks like this. Somewhere in our code, we have something like this, and at execution, we are reaching this point in the program. Let's assume that we have a class hierarchy that looks like this. We take a look at what is the object in here. If it is an object of type A, then if it is type B, to make it a bit more interesting. If it is an object of type B, then we take a look at class B and see, do you have any M method defined here? If that is the case, then we are executing this method. Otherwise, we go up and look in A. So we must, every time we are resolving or binding a call like this, we must find out what is the current object value here, what is the type of the object used here. And we are using this information, then we go into the class hierarchy and using this approach to find which method M that will be executed. This makes Java slightly slower than programming languages which are not using dynamic typing. Can you mention a language which are not using dynamic typing? What? C, yeah. Any old imperative programs like C and ADA, they don't have inheritance, and that means that they are, we can always figure out just by looking at the code where it will jump after this one. It's decided. Okay, 4A. 4B. What separates an abstract class from an interface and an ordinary class? What was an abstract class?
Something in the middle.
What?
Something in the middle.
Something in the middle will get you 1 point out of 5, if I'm kind.
Class can be inherited.
What?
A class that can be inherited.
Can you please name me one class which cannot be inherited?
Sure.
They can be, you can inherit from it. You cannot create an object of an abstract class. You meant that. Okay. Yeah. An abstract class, you can think of it as something in between an interface and an ordinary class. An interface is just a skeleton showing a number of methods with no implementation. An abstract class contains both abstract method, that means empty method, but also implemented methods. And usually they are an inner node in the class hierarchy. We are inserting a shape class to help us implement a rectangle and a triangle and things like this. But they are recognized. How do I recognize in my code an abstract class? The abstract keyword, so it's rather straightforward. Oops. So this was the example I had at lecture time, a public class shape, and here I have inserted abstract to point out that this is an abstract class and it contains 2 abstract methods. That means we have decided that everything which is called a shape should have a method called getArea and print, but we have not provided any implementation of them. Anyone inheriting from this one will get this functionality for free. They don't have to do it, it's just inheriting this functionality, but they must provide their own version of getArea and print. So an abstract method is a method with no implementation. If a class has an abstract method, it must be declared as abstract. So if you're introducing this type of methods, you must introduce this one, otherwise the compiler will complain. And if you're inheriting from this one, this is shape. If you are inheriting from this one, you must provide an implementation. Otherwise, the other class will also be an abstract class. It is not possible to create objects of abstract classes. An interface is a completely abstract class. All the methods are just signatures and they don't provide any implementation at all. So an abstract class is something in between an interface and a concrete class. That's your point. We also had here it is not possible to create objects of abstract classes. That's maybe a point during the exam, but we need a bit more. Subclasses, for example, rectangle and circle, implement their version of the expected behavior. The abstract methods, they can also implement class-specific behavior, for example, get diamond in circle. That means in a subclass inheriting from an abstract class, you can add your own methods, extend the set of possible methods, but you must provide your own implementation of the abstract methods. So I think of abstract classes as some kind of artificial inner nodes in the class hierarchy, representing common behavior and implementation of a set of similar concrete classes. In this example, we were interested in graphical objects like rectangle, triangle, and circle, but we realized that many of them have so many things in common. That's why we are introducing the shape class as an artificial node and are using this one to simplify our implementation of classes, rectangles, and things like this. It's not the only reason. The most important reason is polymorphism, that we can treat all of them as a shape in a uniform way. Okay? All done? How many points would you have so far out of 40? 32? Binary search trees, one of my favorites. They are often occurring in my written exams, I should say, in one way or the other. Consider the Java source code fragment below, representing a binary search tree for integers where the methods add and contains are incomplete. Write down Java code for these two, what these two methods should look like. So here I have a skeleton outlining a class called int BST, and this class is using an inner class BST that looks like this. If you're calling the add method on the tree, it will check if the root is 0, and if it's 0, it just adds a new BST node to the root. Otherwise, it delegates the question down to the add method. And your task was to implement the add method and the contain method. What was the basic idea for adding? First of all, you should say the word recursion here. Recursion is important, otherwise you will end up in trouble, I can tell you. And you are basically, we have a tree. We have a node 7 here, and we have 5 here, and we have 3 here. No? Always larger values on the right-hand side and smaller values on the left-hand side. And we want to add the value 8 here. In each node we do this following thing. We start by comparing 8 with the current value. If it is the same, then we are done. We shouldn't add any duplicates, so then we are returning without doing anything. If it is larger than 8, then we are delegating the question to this one and said add 8 to this one. If it's smaller, we're asking add 8 to this one. It's done using this one. So the add method looks like this. If the value is smaller than the node value, then we should go left. If left is null, then we are just attaching a new node. Otherwise, we are delegating the question to the left node, saying, okay, add n to yourself. We do the same thing on the right-hand side if n is larger than the current value, and if it's neither smaller than or larger than, then it's duplicate element, and we don't do anything down here. Contains basically the same code, but rather than adding something, if we don't find it, we are returning false, saying that we haven't found it. So if I'm looking for n in the tree, then I repeat the following in every node. If n is larger than the current value, go left. If it's larger, go right. If we don't have any left, we are returning false, and if we don't have any right, we are returning false. That means if we can't find it, it should be down here, but we can't find it down here, then it's not in the tree, and we are removing it. Okay? That was basically it. You could have done this in 1 hour, but you shouldn't. You should make a good effort, and then you should read it carefully, and then you should rewrite it in a way that makes me happy. Because if I'm happy when I'm reading your written exam, the outcome will be much better for you. So I get angry when I see students hand in papers that I can't read, and I see that they handed it in after just 1.5 hours. But basically they're taking their problem and giving it to me, and I don't like that approach. So what?
Can you use a typewriter?
No, you cannot. You will only use paper and pen in there. First of all, about 50% of the exercises will involve Java programming. Write a method that do this or write a method do that. The rest will be theory. So I would say that as a preparation, focus on understanding the assignments. If you know how to implement, if you understand your own solutions to the assignments and they passed, you will be well prepared for this exam. Focus on my lecture slides. It happens, but it's rather seldom that I ask something which I haven't presented. Ask about something which I haven't presented at the lecture slide. So if you're short of time, focus on things that are presented in my lecture slides. Use the book to learn things you don't understand. Reread my lecture slides, things you don't understand in the lecture slides, go to your book and hopefully they will come up with a better explanation than I have. Yes?
Is it possible for JavaFX to appear?
It is possible for an exercise related to all things presented in this course. Yeah? Good question. Yeah?
Will there be a Swedish version?
No, I plan to only give an English version of the exam. Actually, we had a few problems in the Java 1 course. I used a Swedish word and a few Swedes didn't know the word. And then I had to explain it in English to them. Method overloading, metodöverlagring I call it in Swedish, which was a bit strange. Is it a problem?
No.
No? Do you have more questions?
I had a question regarding JavaFX. If you have to draw animation or something.
You should have in mind that I don't... I'm not an evil person. So I will not ask you to implement the graphical user interface like the one in Eclipse or something like this. If we are asking something about JavaFX, it's something that we expect you should remember from, have done simple. How do you add functionality to a button? Something like this in JavaFX. At exam time, read the entire exercise carefully. I always tell the students this one. Still, we have students who only read the first part of the exercise and answer the wrong question. So read the entire exercise carefully before you start to give any answers. Answer our questions, nothing else. We do not hand out any points for well-structured text about a non-related topic. It only makes us angry. We will have about 100 exams to correct, and if we have to read 3 pages about something non-related, it makes us angry. If you don't understand the question, ask visiting teacher. Most likely I will visit the exam after about 1 or 2 hours. If there is some part of so start by reading the entire exam, and if there are things you don't understand, I will show up and you can ask me. I will not give an answer, but in most cases, but still, you have the opportunity. Still in doubt and the teacher has left, explain your problem, make an assumption and continue. I don't understand if the question is about this one or that one. I think it makes more sense in this one since something. I try to answer that question. That's the best approach you can do. Relax and do it properly. You have plenty of time. You have 5 hours. Did any one of you spend 5 hours in the Java 1 course?
I think 4.
4, good. Did you pass? Yeah, you see. Stay for 4 hours and basically pass. I do not give any promises, but it's more probable that you pass than if you go after 1 hour, I can tell you. That was it. This is the final lecture, and you will probably not see me until the 3rd year or something like this. I usually have the Android course, but most of my teaching is in the master level course, year 4. So it was nice meeting you, and good luck with the exam and your programming in general. See you.
Thank you.